the optimal strategy. And if you are playing max, you have to go for a maximization. That is, you have to edit the value of alpha. And if you are playing minimization, you have to edit the value of beta. This was what was discussed last class. And the initialization values was minus infinity for alpha and plus infinity for beta. Okay, so the place where we went wrong was, okay, so this is going to be the pruning condition where alpha is greater than or equal to beta. It need not be the maximum of all the values should not be the root node, or similarly the minimum of all the nodes should not be the min node of the parent. Okay, that need not be the case. So whatever is going to be the optimal strategy for both the players, that would be the max value which is placed at the root node. Okay, so the important points what we have to remember is, while we move from the parent to the child, okay, so in that case you will be passing alpha and beta values, right? Whatever alpha and beta values the parent has, that will be shared with the child node. And while going back, that is from the child node to the parent, when you are backtracking, you will be passing the value of s, which is nothing but your node value. Okay, fine. So you have a problem given here. You have the strategies played as max, min and max. Okay, so initializing the values, you get alpha is minus infinity and beta is plus infinity. So as I told you now, when you're moving from the parent to the child, you will be passing down the values of alpha and beta. So B will have minus infinity as alpha and infinity as beta. Then coming down to D also, alpha is minus infinity and beta is plus infinity. Okay, now what you should do, you have the terminal nodes next. So you have to change the value here for this particular node. How do you change it? Since it is maximization is the strategy played, you have to change the value of alpha. So now alpha becomes equal to maximum of minus infinity comma 2. So what happens? Alpha will be equal to 2 here. Now come back here, and beta is still infinity. You're not changing beta values. Okay. Now coming back to this node, what happens? 3 is the node value which goes up. Okay. So when 3 goes up, maximum of 2 comma 3 you have to take. So when you take maximum of 2 comma 3, 3 is assigned to alpha and maximum of earlier alpha value was 2. So 2 comma 3, that is going to give you 3 as your max value. So now this is your alpha and beta updated values. Okay. Now what you should pass from the child to the parent, it is nothing but your node value. What is the node value here? Since it is maximization strategy, the alpha value becomes your node value. So D is equal to 3 is passed on from D to the node B. Okay. So now when you go back here, what is the value you have? You have to find out the values of alpha and beta. Okay. Now what was the earlier values of alpha and beta if you ask me? Alpha and beta was inherited from the parent. Okay. So you will be initially having the value of alpha as minus infinity and beta as plus infinity. Now what you have to do is, you have to take the node of value of s is equal to 3, and that value is assigned to beta. Why it is assigned to beta? Because it is playing the minimization strategy. Okay, so now alpha becomes minus infinity and beta becomes 3, right? So now the value of beta is 3. Now coming back to this node, that is from B to E. So when it moves from the parent to the child, what is inherited? Minus infinity and beta is equal to 3. That is inherited here. Okay, so when that is inherited, beta will still be equal to 3, but alpha is equal to minus infinity. So what would be the value of alpha here? Since it plays the maximization strategy, alpha will be equal to 5, right? So alpha will be equal to 5 and beta will be equal to 3. Why alpha is 5? This 5 goes up and alpha is updated. Okay, so now alpha is equal to 5 and beta is equal to that which was coming from this value. Beta is equal to 3. Now you have the condition alpha is greater than or equal to beta, right? So here you have this condition of pruning, alpha being greater than or equal to beta. So what you have to do is, you can prune this particular tree. Okay, so now what is the value of this particular node? Value of E is nothing but, it plays a maximization strategy. So alpha value is nothing but your E node value, that is S is equal to 5. Now what you should do, you have to send this 5 back to B node. Okay, when you send 5 back to B node, it has to be updated in beta because B plays the minimization strategy. So when you say beta is 3 comma 5, the minimum value will be chosen. Okay, so what happens here is beta will be equal to B will be equal to 3, the minimum of 3 comma 5, right? So this is the value of beta. Now that B value is assigned as 3. Now going back to A. So what is going up from the child to the parent? S is equal to 3 goes up. Now where is that S is equal to 3 gets assigned to? It gets assigned to alpha because A plays the strategy of max. So alpha is equal to 3 and beta is equal to infinity. So that value comes down to C, inherited, right? So alpha is 3 and beta is equal to 3. So here you can see that that value comes down. Alpha beta is inherited, right? So then what happens? The same alpha beta value goes down. Alpha is equal to 3 and beta is equal to infinity, right? Now what you should do is you have to take this value of 0 and this value goes up, S value, and that gets assigned to alpha. Why alpha? Because this is a maximization strategy. So what happens here? Alpha is 3 comma 0, which is maximum. 3 only is maximum, right? So 3 is still there. Then coming to 1, what happens? Alpha is again 3 comma 1. That is, you're taking this maximization, you're checking whichever is maximum, so you get alpha is equal to 3 again. So this value is not changed. Alpha and beta is not changed, but then the value is S is equal to 1 is going up. Okay, so now the value assigned to F is not alpha value, but then it is the maximization strategy played by this node, which is 1, maximum of these two only. Okay, so whichever you take from the node values, that is from the child values, only has to come to the next place, not the alpha value, but that gets assigned to alpha when it goes up, right? But here this doesn't get assigned to alpha. Why? Because it is less than the alpha value. Okay, but you're not pruning it also because alpha is not greater than beta, right? So this value goes up. Then what happens? Now this is playing the minimization strategy. Okay, so when this node plays minimization strategy, what happens? S is equal to 1. So S is equal to 1 means the value of beta is updated because this is minimization strategy. So here if you check, alpha is equal to 3 and beta is equal to 1 satisfies the pruning condition, which means this part of the tree gets cut. Okay, so you don't have to come down anywhere further behind this, below this, right? So now this is alpha equal to 3, beta is equal to 1, and the value of this node S is equal to 1. C node value is 1. So now when I go up, what happens? The value of 1 goes up. Okay, and here what should I update? You can check, alpha is already 3. So now I just have to take the value of S is equal to 1 here and compare it with the existing alpha. So I find that alpha is equal to 3 is the highest value. So I'll not update this 1 here. So alpha still remains 3. So now S is equal to 3. Okay, so the highest of these two, 3 is there. So that 3 is assigned to A node, right? So that's all. So that A node is equal to 3 is going to be the optimal strategy that has been played. Okay, now where did that 3 come from? So that 3 came from A, B. Now leave out the pruned values. So leave out all this. Now if I choose ACF0, I don't get a 3. Only if I choose A, B, D and 3, this is the path chosen, which means if A, the first player plays maximization, player B plays minimization, player D plays maximization, I will be getting a optimal strategy which has a payoff is equal to 3. Okay, so that is how I have to conclude to my steps, right? So this is similar to finding a stage where you play X plays, XO game, X plays, O plays, X plays, and finally here you get a payoff value which is equal to +1. So you will be having +1, -1, +1, -1, and so on in the terminal nodes. Okay, so which strategy you have to choose to find the +1? That would be the optimal way of doing it. And in alpha beta pruning, one more advantage you have, you don't have to go through all the nodes, right? You can prune some parts of the tree so that you achieve the value of the root node in optimal number of steps, right? Complexity and all we have already seen. So what would be the complexity? If all the nodes are traversed using DFS, depth first search strategy, it is order of BM, right? So I mean all the nodes has to be traversed. So if I split it into if I just search only half of the tree, then that M would be equal to M by 2 in the optimal case, right? So that is going to be your complexity of it. So that is all about my alpha beta pruning. I just have one more small problem for you. I think we can quickly give me the answer for this. Okay, now you have, yeah, right. So these are all the terminal values. I couldn't draw like that, so I've just made it as a hierarchical diagram. Okay, so here the first value is max, min, and then these are all my payoff values. So quickly, let us solve this problem of, so what happens initially from my first max node, my alpha and beta, I call it as A and B, comes down to my first node over here because this is DFS. Okay, so I call this as A node, then I mean the next node is here. Then I come to this node. Here also alpha is minus infinity, beta is plus infinity. Here I come, alpha is plus infinity and beta is, I mean minus infinity and plus infinity. So now what happens here? That is my question. So what happens here? Can someone give me the solution for this? So I have the value of 4. What has to be assigned? The value of 4 has to be assigned to beta, right? Why? Because that is playing my minimization strategy. Okay, so that value of beta is equal to 4. What happens is going to be called as my minimization value, because this whole layer is following the minimization as my strategy. Okay, since I have only one value here, so this whole thing, this node, I can call it as S is equal to 4. So that value which is being assigned to this node is only 4. So similarly, I can say that here also the value of S is equal to 3. Okay, but when this node goes up, what happens here? I have alpha is equal to minus infinity and beta is equal to plus infinity, right? This is minimization, but this is maximization. So here when I go, yes,
Nothing, ma'am. Continue, ma'am.
yeah, okay, right. So now this plays maximization as my strategy. So what happens? I will initially update this value of alpha to be equal to 4. Okay, so this is maximization. So S value goes up. S value is equal to 4 gets updated to alpha, but beta still remains the same. Now, when I come to this, okay, oh, you meant to say that I have to go like this and come down, right? Correct. So after I come down here, right? So after I finish this node only, I'll come down here. So when I come down, I'll inherit the values of alpha and beta. Okay. So what I will do, I will take the values of A is equal to 4 and not getting copy. A is equal to 4 and B is equal to infinity. Yeah, now initially it is infinity. Then what happens? I'll be assigning the value of 3 to beta. Okay, so this becomes 3. Right. Now what happens? I have to go and update my root node. So while going back, what happens? This is my minimization strategy. Max, min, max, min. So what happens? S is equal to 3 is updated. Okay. So this node value is 3. So when I go up, this is maximization. So what happens? A is 4 comma 3. So I'll still have only 4. This 3 will not be updated here. Got it? Because this plays my maximization. So maximum value is 4 only. So that only has to be updated, right? So now what is my root value here? I mean, the node value here is s is equal to, so I
4.
have, yeah, right, s is equal to 4. Now this value of s is equal to 4 goes to this particular parent node. From s is equal to 4, I just pass it on to this value. Okay, now s is equal to 4 is passed, but then we'll see what happens. Now I'll be having the value of, what is the value of this node of alpha and beta? It was inherited from this particular value, right? So that still remains the, which is minus infinity and plus infinity. Now where will this b gets assigned to? The question here, it is minimization, so it gets assigned to beta is equal to 4. Okay, so beta becomes 4 and alpha still becomes minus infinity. So now what I should do next, I have to take this value and send it to the next node over here, right? So when I send it to the next node over here, what happens? I take this value and I'm sending it to this value. So alpha is minus infinity and beta is 4. So the same value, what I should do, I have to send it to this place. So I'm inheriting the values of the parents and I am putting it here. What's happening? Okay, so the same values of whatever I had here, that has been inherited here, and the same value is inherited here also. Okay, so now this node plays the strategy of max min, right? So when I say min is played here, now what should I do? Now should I change the value of beta to be equal to 4 comma 6? So what is the value of beta for this node?
4.
4. Okay, so value is 4 only. But what would be the node value here? Beta is 4. Okay, but what would be the node value here? S value. Node value means S value.
4, I think. It's minimization strategy in that layer. Right?
Yeah, minimization is a strategy played, right? So, but the immediate node over here, the payoff value for this node only should be assigned to this, right? You're changing the value of beta here to be equal to 4. That is perfectly right. But would be the S value that is being changed. If you have followed this problem here, you could have noticed one statement which I told. Right. So I had alpha is equal to 3 and beta is equal to 1. Okay. So when I brought it down here, alpha is equal to actually 3 comma 1, right? So I'll be assigning 1 only this place when I played this here. So alpha will be changed to be equal to 3 only. Okay, it is not changed as 1. Though alpha becomes, you're assigning this 1 to alpha, what happens? Alpha still remains 3 because the maximum of 3 comma 1 is 3 and beta is still the 1. Okay, I'm not changing beta at this place because this place maximization strategy. But then the node value which is assigned to F is only the 1. 1 means S value which is taken from the child node to the parent node. Okay, I'll not take the value of 3 to be equal to my node here. Okay, so don't make that problem. I mean, don't make that mistake there. So now when I come here, right? So I have 4 comma 6. So the value of beta, this is playing what strategy? Max min, max min. Yeah, value of beta would be equal to 4 only, no doubt about it. Okay, but the value of s would be equal to 6. Okay, so now this value, when I take it up, the value would be equal to s is equal to 6. Now where is the value of s being assigned to when it goes up? So this happens to be my maximization strategy. So I'll be assigning the value of alpha to be equal to 6. Minus infinity goes off. Okay, so now I have alpha equal to 6 and beta is equal to 4, right? So I copy this, and while inheriting I will bring down the values of alpha and beta. So I'll be inheriting the values of alpha and beta, which is a is equal to 6 and b is equal to 4, right? So this value is brought down, but then what happens? You also have s value which is equal to 2. Why? Because actually this s is assigned to this. This is playing min, max, min. Okay, so actually this has to be changed. Which has to be changed? B is equal to 4 comma 2. So the minimum value will be chosen. So B is equal to 2. Okay, and S is also equal to 2, right? So this is how I get the values of alpha and beta. So now what happens? S is equal to 2 goes here, right? Oh, one more. Okay. Now listen. Should I do this step at all here? Just look into this node and tell me whether I should come down and do this step. Earlier I had minus
No,
infinity,
ma'am.
right? Why no? Because,
Alpha is greater than equal to beta.
but how did I get that alpha is equal to 6? This s is passed up, that becomes my maximization node. So alpha is assigned the value of 6 and alpha is greater than or equal to beta. So I don't even have to do this step. I just have to prune at this particular layer, right? Alpha is greater than or equal to beta. Sorry. So I prune this and I prune this. These two. These two are pruned because my alpha is greater than or equal to beta at this step. So next, what should I do? Just one more step will solve, then move on to the theory part of it. Now I have my alpha and beta values here. What is going to be my S value for this node? S value is the child value which was passed here. I mean the node value which was passed here is the values over here. So what happens? S is equal to, it plays what strategy? Max, min and max. So S is equal to 6. Okay. So now I have S is equal to 6. And what should I pass to the upper node? The value above. Only then this value gets changed, right? So this plays minimization strategy. So when this plays minimization strategy, the initial value of alpha was alpha is equal to minus infinity and this is beta is equal to 4. Now what is beta is equal to? Beta will be equal to 6, correct? Because I have the node value as 6. So what would be the actual values of alpha and beta here? Node value is 4 because this is playing minimization strategy. And the values of alpha and beta would be, alpha will not be changed because I'm playing minimization as my strategy. And beta would be equal to, beta would be equal to still 4 because minimum of 4 comma 6. It is nothing but 4 only. Okay, so I have this as my values of alpha and beta, right? Then moving up, I go to my root node. So when I go to my root node, what should I change? I have to change the values of alpha and beta, right? So now the value of the root node here. So what goes up? S is equal to 4 goes up. That 4 gets assigned to my alpha here, right? So my alpha becomes equal to 4 because S is equal to 4 here. And my B is equal to, no, this B is equal to 4 is for this. Initially, what did I have as my alpha and beta? Beta was minus, just infinity, right? So that was my values of the initial root node. So just remember once again, while going up, my root node values will be taken up, but then the alpha and beta will only traverse down. So this was initialized with alpha is equal to minus infinity and beta is equal to plus infinity, right? So here, when I pass up, I'm passing up the value of S is equal to 4. That S is equal to 4 gets assigned to alpha. Why? Because I'm playing the maximization strategy. Beta still remains infinity. Okay. Now coming to this, why have not taken into this one into account? Because I have, should I traverse it or not? This particular node. No, this node is not there. Sorry. You don't have a continuity here, so I just remove that node. Right? So this node I have pruned it, and then this values I have passed on to the root node. So now what I should do, as per my DFS strategy, I have to take down this value of alpha and beta, and I have to come down, right? So when I come down, what happens here? This value is brought down here, and while coming to the child node, I am using the same values of alpha and beta, right? Then while coming down also, I am using the same. So I use A is equal to 4 and B is equal to infinity. Now what should I do? I have to change this value. So this max min. So what should I change? This value of 2 will be assigned to beta. Okay. And the value of S is also equal to 2. Right? So when I go up, what happens? This value of S that I take it up is 2, and that value gets assigned to max min max. So where does it goes? It gets assigned to alpha, right? Because this is playing maximization as my strategy. And the value of, so when I say max of 4, 2, it is obviously 4, and the value of S is equal to 2. Okay, so now what happens? I will inherit my alpha and beta values. So when the next step comes, A is equal to 4 and B is equal to infinity, right? So now what happens? This plays max min minimization strategy. So what happens? Infinity, this value will be assigned to be equal to 1 and S value is equal to 1. Okay, so this S value will go up. When it goes up, what happens? Now this max min max. Okay, so S is equal to 1 goes up. So what happens? The value of A is equal to 4, 1. So it gets assigned to alpha. So still alpha becomes 4 only and beta becomes infinity only. I'm not changing beta because this is maximization strategy being played. Okay, so now what happens? The value of S is equal to 2 still remains because this is maximization. Maximum of these two, I'm putting it here, right? Now going up one level high, the value of S is equal to 2 goes up. Okay, and A is equal to 4 and B is equal to infinity still remains the same, and S is equal to 2 gets assigned to what? Minimization. So it is no longer for alpha, it is for beta, right? So beta becomes beta is equal to 2. This S value gets assigned to this value. right? So now if you can check, alpha is greater than or equal to beta. So what will I do? I have to prune this tree and this particular tree. I don't have to go through these two trees. Okay, I can just stop with this because alpha is greater than or equal to beta. Okay, so what do? I just prune it. So when I prune this, obviously I cannot come down further. Okay, I'll prune this part also. So these two trees are pruned because this condition is satisfied. Now what do? Again, I take this value of s is equal to 2 and I go up. When I go up, what happens? A comma, the 2 gets assigned to 4. So A is equal to 4 comma 2. So 4 is maximum. I retain that 4. So I just put s is equal to 4 only. Okay. So that is the maximum value, 4 only. And I have to come to this right part of the tree. So when I come here, what happens? Again, I'll be having A is equal to 4, inheriting the values. B is equal to infinity. Okay. And that's it. So those alpha and beta values, I'm just inheriting it here. Nothing more I have done. So same thing, I'm inheriting it to this part. Also inheriting to this. Oh, sorry. Type it better. Okay, A is equal to 4 and B is equal to infinity. So that is inherited to this place also. A is equal to 4 and B is equal to infinity. So when it comes to this place, this is actually playing max min. So B is equal to 5 and S is equal to 5. So what do I take up? I take up S is equal to 5 and that 5 is assigned to 4 comma 5. So because that is maximization strategy. So A becomes now equal to 5 and that S is equal to 5 goes here. Okay. So S value going up and that is updating the value of alpha. Right. Now coming down here again. So what happens? I have A is equal to 5 and B is equal to infinity, and the value of 4 will be assigned to alpha beta here, right? So why it is assigned to beta here? Because this is minimization strategy. Max min, right? So S is equal to 4. But still, you don't have to go through this because you have this value of A greater than or equal to B. So anyway, I'm not going to use this. So this part is pruned. Right. Okay. Now, what do I pass up? I pass a value of S is equal to 4 to my parent node. So S is equal to 4 goes up. That is assigned to max, min, max. Okay. So when I say max for this, S is equal to 4. No, S is equal to 5 only. Why? Because 5 comma 4, 5 is the maximum, right? So the value of S equal to 5 goes here. So when it goes up here, what happens? This is what? Minimization. So B is equal to 5. Okay. So that S is equal to 5 gets assigned to beta. Now what should I do? I have to take the values of A is equal to 4 and B is equal to 5. Alpha is less than or equal to beta. So A is equal to 4 and B is equal to 5. I am inheriting the values of alpha and beta. So this place max, min. So 5 comma 7. So what happens here? 5 only is minimum, but S is equal to 7. Okay. So when I go up, what happens? S is equal to 7 goes up, and that 7 is actually max, min, max. So that 7 is updated over here. Okay, got it? Because value of S is equal to 7. This is playing maximization strategy. So 7 gets updated to this A value. Okay, and the value of S is equal to 7. Okay, now what happens? Alpha is greater than beta. So I'm not going to use this part of the tree. This part of the tree is pruned, right? So that's all about it. Right. So this part is pruned, which means obviously I cannot come below this also, right? So now S is equal to 7 goes up. Goes up means go to this node. So what happens here? Which one should I change? I have to change beta because this is minimization. But minimum of 5 comma 7 will be still 5 only. Okay. So I will be having the value of S is equal to 5 only here, right? So from here S is equal to 5 goes here, right? So when I say 5 goes to the top, so S is equal to 5 gets assigned to A value here. Okay, so that's all. So A is 5 and B is infinity. So this is the problem. So that is actually solved. Now you have to check, where did I get that 5? Through which path did we get 5? So one path that is active is here. S is equal to 5, this, infinity, this and this. So you can highlight this particular path, right? That's all. So this is going to be the path that you're going to choose. So the optimal strategy that is being played is A plays this, B this, then the next player this, then this, and then comes to 5. So this is the optimal strategy being played, right? I think now you're somewhat clear. So one mistake that we have done in last class was, while taking the values of alpha and beta, you have to inherit it. And S value, what we did was we assigned to alpha or beta depending on the strategy played. Okay. And one more thing, that we did, but then the S value we took maximum of, if I was playing maximum. So suppose if I had 4 comma 1, say for example, so that value whatever I've assigned to alpha, that also I have changed the value of S, but that should not be done. Okay, alpha and beta remains unchanged. You just assign the value of S to either alpha or beta depending on whether it is maximization or minimization strategy. Otherwise, don't touch alpha beta. This S value should be from the child node to the parent node. You just have to keep traversing it. Only then you will get one value at the root node, and the same value wherever you have it at the child node, like the leaf node. So that has to be traversed, and then only you will get the path of the solution, right? So I think till this alpha beta pruning is clear. Is it? Can I move on to the next topic? Right. So the next topic here is, we started with expert systems, applications of artificial intelligence. One such application is the expert system, developing an expert system. And one expert system, what we are going to see is, you can write any one of these 3 expert system. But Mycin is, if they ask you for a part C question, probably go with Mycin because that is somewhat elaborate, right? So what is Mycin? We have seen this already. It's a medical expert system, and it was developed by Stanford University to diagnose the diseases. Okay, so diagnose diseases means I can be a normal user of the system. I don't have to know medical terminologies, but using the medical experts, they have developed this system so that whatever inputs, the diagnosis data I give, blood test reports, and then whatever inputs I give for the system, it will diagnose my disease. Okay, and it was written in Lisp programming. Now, how many rules does it have? It has around 600 rules. So it will go through all the rules, and depending on a few rules which matches the given conditions, right, it is going to give you the diagnosis. Okay, so I'll show you the diagram here. You have similar to your normal architecture, expert system architecture, right? So what all you had in your expert system architecture, you had the dynamic knowledge base. Okay, then you had something called as knowledge acquisition system, wherein you will have all the experts, say for example doctors or lawyers or chartered accountants. According to the expert system that you build, you'll be having experts, and they will be feeding the knowledge acquisition system. Now what this expert system will do is, whenever a question or answer is asked, it is going to give you a solution for it. And along with the solution means diagnosis, right? Along with the solution, it will also have an explanation system stating why that particular solution was arrived, how it was done, depending on the rules it has chosen from the static database. Where did I stop? This slide or previous slide? Where did I stop? Consultation system, right? Hello? Okay. Right. So you have to check what are all the infections reported in the blood report, like bacteria or virus, whatever it is, right? So all those will be the inputs taken, and depending on the inputs that has been taken, what are all the organisms they'll call, like Salmonella typhi for typhoid. Okay, so those things will be fed by the user, and then what are all the drugs that were initially taken, and depending on that, this is going to also suggest that if it was typhoid or if it was malaria. So it will also suggest, along with the disease, what are all the drugs that you have to take, right? So this is going to be the consultation control structure. Now what is it using? Obviously the DFS tree, and then it is goal directed backward chaining. So you know the symptoms. So what would be the origin that, what would be the disease that has led you to shivering and fever? So this is going to be a goal directed backward chaining approach. Okay. Now, these again the same consultation system, you're going to explain it as a theory part. So what are all the data that you're going to take as user input? What is that you're going to check with the static database, right? So that with this information, you'll be creating the explanation system. If you write this much of theory, that is enough, right? So QA module is, you can ask the expert system, why are you saying that I have malaria? Why can't it be something like some other disease, right? Because apart from apart from shivering and vomiting, I also have some other disease like a severe migraine. So it can be something else also. Depending on two symptoms, you cannot call it as malaria. So if you post a question like that, probably it will go and check again in the database, saying that if all the three things are there, but no headache, not very frequently, once in a while I get headache. So if such a condition is there, probably it will refine the explanation and give you another solution. So that is your QA module, right? So that is all about my Mycin expert system. So it is a system wherein you talk with a system which was designed by experts, and you can get your diagnosis done, and along with the diagnosis, you can also have your drug recommendation. Okay, so that is all about Mycin. Next, moving on to DART. DART is again another program which will automatically identify your computer faults. So when I say you're not a diagnostic person, you don't have much knowledge of what went wrong somewhere. Okay, but you can just tell the system that probably you get a information or some instruction in the computer saying that it automatically goes off, or some RAM failure happens. So it has to diagnose what happens, right? So as your system engineer is going to do some levels of diagnosis, if you say that what are all the problems that you have encountered in the system before the computer actually failed, this will help you in automatically diagnosing where the the fault has actually happened. Okay, so again for this, the backend is fed by all the information that would be aiding you towards the development of the expert system, right? So DART full form is dynamic analysis and replanning tool, right? So this is for computer diagnostics and software testing. Then moving on to the next, you don't have an architecture and all, this is just what is DART and where is it used. Similarly, what is XCON and where is it used? That is going to be the small information that was given in your book. So what is XCON? It's expert configurer. So here, actually, it was used initially by this DECVAX computer system. What they have done is, if you say that you want the computer parts to be like this, okay, say, yeah, see here it's given. It automatically selects the computer system components based on the computer's requirements. So I just give my inputs saying that I'm going to use this system only for deep learning. So I'm going to use it for gaming. Okay, So accordingly, depending, I'm going to use it only for typing. I'm going to use it only for my um, PowerPoint presentation. So depending on that, so what level of computer you have to select, what should be a configuration of the computer, that would be recommended by the system. Okay. So once they develop this, the company has seen a tremendous profit, by means of which the time that is actually saved by explaining to the customer, taking back the feedback, and out of so many orders that were received, they found that 95% of accuracy was there. That is, depending on the customer requirements, the product was delivered, right? So customer satisfaction was also improved by using this expert system called XCon, right? Expert configurer. So this was also developed by the CMU University. That's all. So these are the three expert systems that you can give as one of the applications for your, well, expert system is an application for AI. So that expert systems, three different types of expert systems you have to write. Okay. So that is all about your last topic. So your last topic was actually applications of AI, for which we have seen one application as expert systems, right? So this is all about unit 5. Any questions you have with respect to unit 5? I'll show you the topics once again. Topics. We started with important concepts of game theory. So here you saw something about saddle point. Min max should be equal to max min, that is saddle point. And then coming to gameplay. So that strategy is actually played by the person who has to who is in the role of taking the right decision. So how do you take the right choice? So that is all about the game playing and knowledge structure. Then game as a search problem, all your tic-tac-toe problems, how do you search, and all these things. And min-max problem, okay, wherein you try to find out the minimum or maximum of each and every node by going through all the nodes. Then coming to alpha beta pruning, you have to learn the pseudocode of it along with the problem solving. Then coming to game theory problems, you had identifying the Nash equilibrium, and then finding out whether dominant strategy is played, and if it is dominant strategy, then how do you reduce the problem into a without having the dominant strategy. So that was covered in game theory problems. You also saw two different strategies, which is pure strategy and mixer strategy. So if it was pure strategy, it is either 0 or 1. If it was mixer strategy, then probabilities are associated with each strategy that was played. Okay, so these were covered in your game theory problems. And finally, we saw different types of expert systems. The architecture, that's one big part C question. Explain the architecture of expert system. And the different types of expert system, if they ask, it is rule-based, frame-based, and fussy-based. So rule-based, you will give one example. Frame-based, again with one example, covering all the object-oriented programming concepts. And fussy-based expert system, you will give one example, either air conditioner or washing machine or refrigerator. Okay, so you can design your own fussy-based expert system. And finally, coming to case study in AI applications, we saw one case study, which is the expert system shell using whatever. You can explain Mycin or Dart or XCOM. Okay, so that is all about your 5th unit. Any doubts you have, or as usual, no doubts? Yes. How many of you gone through the question bank that was shared